So the power transmission devices, power transmission devices. So before going to this topic, so first of all, what are the power you are developed? What are the power you are developed? That it has to be transmitted for the use. That it has to be transmitted for the use. Say power developed in the case of IC engines, that has to be transmitted to the in through chain drive or and the power which is generated by the electrical energy like electrical power, which is transmitted to transmission lines, likewise the power which is developed, it has to be transmitted, otherwise it will be of no use, because the power which has developed, that has to be transmitted for the purpose of using that particular power. So in the case of IC engines, the power is developed inside the engine cylinder. That power has to be transmitted. The power has to be transmitted to drive the vehicle. So how the power inside, which is developed in the inside engine cylinder, how is transmitted to drive the vehicle. So what by what means? By what means it is transmitted? Like in the case of electrical power, we have a transmission lines. We have a transmission lines to to transmit the power. Similarly, there are transmission devices. There are transmission devices, the power which is transmitted from one shaft to the other shaft. By using that there are four types of transmission devices, where the power which is through shafts, where we are going to transmit the power by using the shaft. Okay, so when you use this one, when you say for example, there are four types, as I told you, there are four types. One is the belt drive. This is called belt drive. Okay, and this is called gear drive. And this is called chain drive. And the fourth one is rope drive, or we can say the wire drive also. Rope is of two types. One is the fabric rope and wire rope. So rope drives are used for lifting, rising the loads, or lowering the height. I mean loads. So whereas in the case of bell drives, we are going to transmit the power when the shafts are very at far distances. When the shafts are at far distances, say the distance between the two shafts. This is the one shaft, and this is one more shaft. The distance between these two shafts, is very far, at larger distances. Then we use the belt drives. We use the belt drives when the distance is intermediate. When the distance is intermediate, I means the distance between the two shafts is very intermediate distance, then we use the chain drives. So if you look at this, the chain drive, we see this is the shaft where you are going to mount this particular wheel, and then this is going to be where you are going to mount the one more shaft. So the distance between these two shafts, is very medium distance. So intermediate distances, for the intermediate distances where we are going to transmit the power, then we are going to use the chain drives. So for transmitting the power between the largest shafts, we are going to use the belt drives. Whereas the distance is very small. When the distance is very small, then we are going to use the gear drives. So these are the based on the distance between the parallel shafts. Based on the distance between the parallel shafts, we are going to use the different types of transmission devices. One is a belt drive, chain drive, and then gear drive. So belt drive is for larger distances of the parallel shafts, and the chain drive is for intermediate distances of the shafts, and then gear drive is very short distances of the shafts. So these are the three. When the parallel shafts are at a different distances, then we use the different types of transmission device. Whereas the rope drive, see if you look at this, this is a conveyor. Where we are going to raise the where you can carry the loads from this point to the another point. So here I am going to use the ropes. To transmit from one place to the other place that particular load. So we are using one more is when we use this one, what we call lifts and all. We can raise the lift and then lower the lift from ground to the highest point, or highest floor. So where we are going to use the rope drives, by using the pulley mechanism. So there I am using the lifting the load and lowering the load. So this is the rope drives which you are going to use. But according to your syllabus, we have only which one, belt drive and the gear drive we have. So we discuss only belt drive and gear drive. Okay. So of course this chain drive, if you observe this particular chain drive, you can see that internal combustion engines. In the internal combustion engines, the power which is developed inside the engine cylinder, which is transmitted to the crankshaft, and then the crankshaft is connected to the rear wheel. The crankshaft is connected to the rear wheel shaft, which is through means of by means of this chain drive, by means of chain drive. So here the in the IC engines we use the chain drive, and suppose if you look at this particular gear drives and all, even the gear drives also for power transmission. In the case of automobiles, we use these gear drives, and the belt and pulley drives might be seen in the floor mills, where you can see that the power, the driver pulley is connected to the electric motor, that is transmitted to the where the floor is going to be grinded, where the floor is grinded. So that is how this application can be seen. And the road brakes, as you said, and the lifts and all, we are going to use the rising and learn. And also for the handling the equipments also, we can use this for the power transmission devices. Next, we'll move to the discussion on the belt drive. So as I told you, this belt drive is, see, there are two shafts which you can call as, one is the driving shaft, or the other one is the driven shaft. So these shafts are mounted by two pulleys, which is called one pulley here, one more pulley here. So which is, say for example, this is a driving shaft, this is a driving shaft which is connected to the electric motor, say for example, and this shaft on which we are going to mount in this pulley is called as driver pulley. Driver pulley drives the another pulley which is called as a driven pulley. Driver pulley or follower pulley we can call as this is a driver and this is a follower, or driving pulley, driven pulley we can call as. These two are mounted on the two shafts. One is the driving shaft, the other one is the driven shaft. So that this type of drive is used when the power is to be transmitted from one shaft to the other shaft, which is at some larger distances, and pulleys are mounted on the driver and driven follower shafts. See here, this is pulleys which you can call as, this is called driver pulley and this is called as driven pulley. So these pulleys are mounted on these shafts, and an endless belt are fitted tightly over these pulleys. So there is no end here, means which is a continuous belt, here. So this is the belt which is fitted onto these two pulleys, So when you, second point, when see this the frictional grip, the frictional grip between the belt and the pulley, the frictional grip between the belt and pulley, that causes the motion, so that we can transmit the power, so the frictional grip, see, the frictional resistance or the frictional grip between these pulleys and the belt, pulleys and the belt is the reason for power transmission, So without the frictional grip between the pulleys and the belt, we cannot transmit the motion or power. So we cannot transmit the power or motion between these pulleys, driver and driven pulleys. So here frictional grip plays a important criteria in this transmission of power, So when we say frictional grip, on which parameters it is going, the frictional grip or frictional resistance is going to depend upon is, there are three factors or parameters. One is, you can say, the tensions on the tight side and slack side, okay, and the angle of contact, the tension side and the angle of contact, and one more is tension, that is the velocity of the belt. These are the three parameters: velocity of the belt, tensions of the belt, and arc of contact, nothing but angle of contact, how much angle of contact can be taken. Let's say if you look at this, it will not be connected, the 360 degrees of this pulley is not connected by the belt. So it is only up to more than 180 degrees it is going to have the contact by the belt with the pulley, So when you look at this, the second point, the frictional resistance between these pulleys and belt is the reason for the power transmission, which depends on the three parameters. One is velocity of the belt, the other one is the tensions of the belts, and arc of contact of the belt in the smaller pulley. So here these belt drives are used where the distance between the two shafts are large. So when the two shafts are which are at a larger distance, then we can use the belt drive. In the case of chain drive, intermediate distance. In the case of gear drive, smaller distances. So here these belt drives are two types. One is the flat belt drive and the other one is the V belt drive. So these are the two belts which are going to use. And in the case of, we are discussing about the flat belt here, we are discussing about the flat belt here. So when you look at this flat belt, when you look at this flat belt for parallel shafts, for parallel shaft, this is the shaft A. So here A is located A, and then B, this is the shaft which is in the top view. So these are the two views he has drawn here. So this is the front view and the top view. So in the top view you can see that the shaft is placed like this, and on over the shaft we mounted a driver pulley. And here is one more shaft. This is called driving shaft. I mean, this is called driving shaft. This is called driven shaft. And on the driven shaft, we have mounted a pulley called driven pulley. We mounted a pulley called driven pulley. So the driver pulley pulls the belt. See, the driver pulley means this is the driver pulley which is going to be pulls. So this is the direction of the pulling of this particular belt. Okay, from one side and delivers it to the other side. Means where we are pulling, this is called as from the bottom of this, then it's called a tight side, and then it is the slack side. So where we are pulling the belt from the driven pulley, it is called as the tight side. The delivering side is called as a slack side. So the tensions in the former side will be larger and hence called tight side. Means this one is called as, because as it is pulling, the tension will be more, so that's why it is called as a tight side. And the other side where the tension is less compared to this tight side, that's why it's called as a slack side. That's why it's called as a slack side. Then one more drive is called as a cross belt drive. So here also I'm using the cross belt drive. Cross belt drive, flat belt only I'm using here. So in the flat belt drive, say for example, this is the, and one more very importantly in the case of open belt drive, see here, if you look at the driver pulley and the driven pulley, both are moving in the clockwise direction. Both are moving in a clockwise direction. So means when you want to transfer the motion which is in the same direction, then I can go for the open belt drive. We can go for the open belt drive. So whereas in the case of cross belt drive, see here the direction of the direction of the driver pulley and driven pulley, direction of the driver pulley and the direction of the driven pulley. So if you look at, both are moving in a opposite direction. Both are moving in a opposite direction. So depending on the requirement, whether I have to move the both pulleys in the same direction or in opposite direction, I can go for the different types of belt drive, mean open belt drive or a cross belt drive. So here when the car in the cross belt drive, the direction of the pulley, driver pulley and the driven pulley is in the opposite direction. So depending on the requirement, when you want to rotate the opposite direction or when you want to rotate the same direction, then I can go for the open belt drive or a cross belt drive. So in the case of cross belt drive, the driven shaft is to be rotated in the opposite direction of that of the driver shaft. So the belt is so arranged in a crossed manner. See, if you look at this is in a crossed manner, means then only you can get the opposite direction. So the belt of this particular thing, it goes under this particular driven pulley and then come back like this. So this is how the cross belt drive is going to be arranged. The angle of contact of the belt on both the pulleys is equal. In this case, in the case of open belt drive, the angle of contact on the both pulleys is not same. Whereas in the case of cross belt drive, we will be getting the angle of contact of the belt on both pulleys is equal. So this is just a description about what is the open belt and what is the cross belt drive. So now we'll move to the slip of the belt. So what is meant by slip of the belt? What is meant by slip of the belt? So slip is nothing but when we know that assuming a firm, because the motion between the belt and pulleys is occurred because of the frictional grip. Because of the frictional grip. Suppose this frictional grip is not sufficient, because the frictional grip, it is not sufficient to run, then there is a chance of, for causes of forward motion of the driver without carrying the belt, because of the insufficient friction, between the belt and the driver pulley. Then the driver pulley moves a little bit than the without carrying the belt. Means there is a relative motion between the belt and pulley is taken place. When there is a relative motion between the belt and pulley takes place, then there is a slippage of the belt is occurred. Slippage of the belt is occurred. So that is what, see here, we know that the assuming a frictional grip between the belts and shaft, the motion of the belts and shaft takes place. But sometimes the frictional grip becomes insufficient. So that will not be sufficient to pull the belt and it transmit to the delivery side. So here this may cause some forward motion of the driver without carrying the belt. Means just that is the belt is slipping on the surface of the driver pulley. So this may also cause some forward motion of the belt without carrying the driving pulley with it. So this is called the slip of the belt. This is called as a slip of the belt. So I will show with one. So if you look at here, see this is called driving pulley and this is called as driven pulley. So the driving pulley is rotating in a anti-clockwise direction. The driving pulley is rotating in a anti-clockwise direction. So here if you look at this in the previous which we have taken is in a clockwise direction. So here if you look at this, where the pulley is pulling this particular belt is called as tight side and this is called as lax side. So there is a, see, shrinking is takes place and then see the length of this belt when you cut into small parts, then shrinkages happen. So here the tight side means this is the pulling, tension is high in this case. So to show that tension is high, the distance between these two vertical lines is larger compared to here. Means this is a slack side and this is a tight side. Means tension in this side is going to be less. So that's to show that and yes, and suppose if there is a frictional grip is not of that much, if the frictional grip is not of that much between the driving and the belt, then without carrying this belt, this driving pulley moves a little further distance. That is called as slip. That is called as slip. So now we'll discuss about the slip of the belt. What is the slip of the belt? And generally, the slip of the belt is expressed in the form of percentage. So what is the percentage of slip taking place between the pulley and the belt? Between the pulley and the belt. So here, the result of the belt slipping is due to the what will happen if the slip is there in the power transmission of through belt drives? There is a reduction in the velocity ratio of the system. There is a reduction in the velocity ratio of the system. So what is the velocity ratio? We'll discuss. What is the velocity ratio? We will discuss. And to reduce the velocity ratio of the system. So as the slipping of the belt is a common phenomena, because the slipping the belt is thus the belt should never be used where a definite velocity ratio is of very importance. Where the velocity ratios are very important, then that situation we should not use this kind of belt drives. So suppose what is the velocity ratio? What is the velocity ratio when you consider the slip? When you consider the slip percentage also. So N2 by N1 is equal to D1 by D2 into 1 minus of S1 by 100 minus S2 by 100. So D1 by D2 is equal to 1 minus S1 plus S2 by 100. So this S1 plus S2 is the total slip within the belt and driver as well as belt and follower. So that will be taken as yes. So D1 by D2 into 1 minus S by 100 will give the velocity ratio. So here because of this it is reduction in the velocity ratio. If S is equal to 0, if S is equal to, because there is no slip, when there is no slip, then we can say that velocity ratio is D1 by D2. Because of slip is occurring, say for example 10%, so we will be getting 0.9. We'll be getting 0.9 means 90% of the velocity. So 10% is the loss. 10% is the loss in the velocity ratio. So slip results in reducing the velocity ratio. So wherever the velocity ratios are very important, then these kind of belt drives are not of much importance. So we cannot use the belt drives. Next, we'll go to the creep. So what is the phenomena of creep? So in the belt drives, these are the two phenomena which occur. That is, the one is the slip, the other one is the creep. So here, as I told you, I have shown this in the animated video. This motion of the belt relative to the driving and driven pulley due to the unequal stretching of the two sides. So unequal stretching, if you have look at this, tight side is the stretching is more, the slack side is stretching is less. That is what you can call as unequal stretching of the two sides. Unequal stretching of the two sides. That is nothing but called as creep. So when the belt moves over the pulley, to transmit the power, the tension in the tight side is more than the tension in the slack side. So which you have seen in the animated video, the tension in the tight side, the tension in the tight side is more than the tension in the slack side. So as the belt is material is going to be elastic in property, having the elastic property, it elongates more on the tight side than on the slack side. So resulting in unequal stretching on both sides, two sides of the drive, unequal stretching on the two sides of the drive. So therefore, the length of the belt received by the driving pulley, is more than the length that moves the driving pulley. So the relative motion occurs between these two. So that is what we can call as creep. So hence the belt must creep back slightly relative to the driving pulley ring. On the other hand, the length of the belt received by the driven pulley is less than the length that moves the driven pulley. So there is a creep backward slightly. So hence the belt must creep forward slightly relative to the driven pulley. The effect of creep back on the driving pulley is to slow down the speed of the belt with respect to the driving pulley, and the effect of creep forward on the driven pulley, it is slow down the speed of the driven pulley. So here the creep forward makes the speed of the driven pulley is going to be reduced, whereas in the creep back it reduces the speed of the belt, the speed of the belt. So to the driving with respect to the driving pulley, thus the net effect, if you look at, then the net effect if we are going to look at, then there is a small relative motion between these takes place, and there is a reduce in the velocity ratio as well, and creep, when you look at this creep and slip, these two phenomena, so slip is occurs due to the insufficient frictional grip between the belt and pulley. The slip is going to occur because of the frictional grip between the pulley and belt. So if there is insufficient frictional grip between the belt and pulley, then the slip is going to occur. Whereas creep is, as we discussed, this is a elastic property of a belt. So because of the elastic property of the belt, creep is going to occur because elastic property means when the tight side, if you look at it stretches more, and whereas in the slack side it stretches very less. So because of this unequal stretching, we are going to get the effect of creep. So creep is due to the elastic property of the belt, whereas slip is going to be because of the frictional grip between the belt and pulley. So this is the creep and slip phenomena in the belt drives. And if you consider the creep, as we discussed, that because of the creep also, we are going to reduction in the velocity ratio. We are going to get the reduction in the velocity ratio. So considering the creep, the velocity ratio is given by N2 by N1. So N2 by N1 is called as velocity ratio, which is equal to D1 by D2, into E. E is called as Young's modulus of the material of the belt, plus and square root of sigma 2. See, this sigma 2 is nothing but the stress in the belt on the tight side as well as slack side. So stress on the belt on the tight side will be taken as sigma 1. Stress on the belt is on the slack side is going to be taken as sigma 2. Tight side is taken as sigma 1. On the slack side it is taken as sigma 2. So when you take the stresses into consideration under the Young's modulus, N2 by N1 is equal to D1 by D2 into E plus square root of sigma 2 and divided by E plus square root of sigma 1. So this is all the when you consider the creep, while calculating the velocity ratio, the velocity ratio equation changes from D1 by D2 to D1 by D2 into E plus square root of sigma 2 by E plus sigma square root of sigma 1. So we are talking about in the slip phenomena and the creep phenomena about the velocity ratio. Because of these two facts, because of these two effects, that is slip and creep, the velocity ratio is going to be reduced. So what is the velocity ratio? So what is the velocity ratio? The velocity ratio here, if you look at the velocity ratio, it is the ratio between the velocities of the driver and the follower are driven. It is the ratio between the velocities of the driver and the follower, or you can say the follower are driven. the speeds or ratio between the velocities of the driver and the follower are driven. So if it may be expressed mathematically as discussed below here, so we discuss how the velocity ratios are calculated. See, if you look at, as I told you, that in the belt drives, this driver pulley and the driven pulley both runs at the same speed. Okay, so when you look at the D1 is the diameter of the driver, then D2 is the diameter of the follower, N1 is equal to speed of the driver and RPM, and N2 is the speed of the follower in the RPM. So velocity of the driver pulley is taken as V is equal to R omega, V is equal to R omega. So when you take the V is equal to R omega, R into omega, omega is equal to 2 pi n by 60. So our 2R will be taken as the pi d. So pi d1 into n1 will become the velocity of the driver pulley. Pi d1 will become the velocity of the driver pulley. Similarly, velocity of the follower, it will be taken as pi into d2 into n2. That is v is equal to r2 omega 2. R2 omega 2. V is equal to R2 omega 2, and so R2 is omega 2 is equal to 2 pi n2 by 60. So 2R2 will be taken as d2. So pi d2 into n2, pi d2 into n2 will give the velocity of the follower. So assuming there is no slip between the driver and follower, then the velocity of the driver equal to velocity of the follower. Then the velocity of the driver is equal to velocity of the follower. So when you look at this, velocity of the driver is nothing but pi d1 n1 from the previous equation, and velocity of the follower is equal to pi d2 into n2. So if you cancel out the pi on both sides, then I'll get n2 by n1. N2 by n1 means n2 is the revolutions of the driving pulley, and n1 is the revolution of the driver pulley. So n2 by n1 is equal to d1 by d2. So d1 by d2. So this is the velocity ratio equation, and assuming there is no slip between the driver and follower. So when there is no slip between the driver and follower, the velocity ratio which you are going to get is going to be n2 by n1 is equal to d1 by d2. So when the thickness of the belt, is considered, then the velocity ratio changes from n2 by n1 is equal to d1 plus t. Means the thickness will be added to on both sides. I mean on the numerator and denominator. So when the thickness of the belt is considered, the velocity ratio changes. N2 by n1 is equal to d1 plus t by d2 plus t. So these are the equations of velocity ratio. When the velocity ratio, there is no slip, n2 by n1 is equal to d1 by d2. When there is a slip, then n2 by n1 is equal to d1 plus t by d2 plus t. And when there is a slip is considered, we have calculated, we have shown that equation in n2 by n1 is equal to d1 by d2 into 1 minus s by 100. So when the slip is considered, the velocity ratio n2 by n1 is equal to d1 by d2 into 1 minus s by 100. So these are the three equations depending on the requirement what is given, and what whether you have to consider or not. The thickness is to be considered, or slip is to be considered, or creep is to be considered. So if these are given in the problem, then we need to go for, depending on that, we need to use the different equations of velocity ratio. So how we are going to reduce this what you call creep and as well as the slip between this. So if you increase the frictional grip of the material, then you are going to reduce the slip of the particular belt. And also if you use the idler pulley, we can create the idler pulley or one more pulley which you are going to use in the belt drives, so that it creates the tension on both sides same. So we can reduce the creep. So now we'll discuss how the length of an open well drive is going to be derived. The derivation of the length of open well drive. Can be derived by using. So here, if you look at, I have taken a schematic diagram. So this is called as a driver pulley. Okay, this is called as a driver pulley, which has the center of the shaft is O1, and this is the driven pulley, which is the center of the driven pulley is going to be O2. Okay, and this is the belt which is taken on the surface of this driver and driven pulley. And see, if you look at the length of the belt, in the sense, if you start from what you call E, if you start from E, okay, start from E, E to F, and then F to K, K to H, then H to G, then G to J, J to E. This total is called as length of the belt. This total is called as length of the open belt. So how we are going to derive this length of the belt equation? So if you look at here, O1 is the center of this, and O2 is the center of the driven pulley, and from Z to E, that is the angle of contact. That is the angle of contact. So here, and alpha is taken as the angle O1 O2 M. So if you take this one O1 to OM, O2 M is the perpendicular which is drawn onto the O1 M, which is drawn onto the O1. So 180 plus alpha plus alpha, 180 plus alpha plus alpha. So total it is going to be pi plus 2 alpha is the angle of contact on the driver pulley, and here pi minus 2 alpha means totally is 180 degrees, minus 2 alpha will give the angle of contact on the driven pulley, So how to derive this? How to derive this equation?